All right, in today's video reference, we are going to look at real numbers and the difference between mainly rational and irrational numbers. So basically, to this point in your math career, you've only been dealing with rational numbers. So this graphic basically kind of goes through the different types of numbers. You started in kindergarten, and like my daughter's age, 4 years old, just with your natural numbers. 1, 2, 3, 4, 5, 6, 7. They're basically your counting numbers. Then, for some reason, they consider whole numbers the same set, but you include a 0. Then, so imagine this has like, kind of like a funnel system here, and maybe this is a cool koosh ball. It goes through here, and then all your natural numbers go through that bucket into your whole numbers. Then, in 7th grade, you learned about integers. So the only new numbers and integers in 7th and 6th grade that he talked about were these things called your negative numbers. So that's that. And then you were kind of introduced to these numbers, rational numbers, more so maybe in 3rd or 2nd grade or 1st grade, whenever you talked about fractions. So this is the big bucket where everything kind of goes into right now. So all your natural numbers, your whole numbers, your integers go into the rational bucket. So rational numbers are numbers that can be expressed as a ratio of integers. That means that you can write the number as a fraction. So if you can write it as a fraction, it's rational. So all these numbers up here, natural numbers, whole numbers, integers, they can all be written as fractions if I put what underneath it? A 1, absolutely. Now they're all fractions, which proves that they're rational. So going back to the definition of rational numbers, of course, when you make that fraction, your denominator cannot be equal to 0. So you can't have 2 over 0 because that's what? Undefined. So of course, what do fractions give you? So like say I had like 3/4. What does that also equal to in a decimal? 0.75. So rational numbers can also appear in decimal form. The decimals, this is important. So the decimals either terminate, which means end, like this one, or they can go on forever and ever and ever with a pattern. Or meaning it repeats, but it has to have a pattern. For example, who can give me a fraction possibly that goes on forever with a pattern? I was thinking 1/3. It's a famous one, so it's 0.3333 repeated. Anyone know what 2/3 is? If you put that into your calculator and did 2 divided by 3, yeah, it's 0.6, and then the 7 repeats forever and ever and ever. And so at the end of your decimal, can someone just remind me what that little hat means? Yeah, it means it goes on forever and ever and ever with that same pattern. So 7s and so on. So then this is again a nice, I have to give credit to Miss Cloutier who gave me this graphic here. So again, just imagine all your natural numbers, your whole numbers, your integers, all going into this rational bucket. Some things that are considered rational are even square roots. So the square root of 49 is 7 because 7 times 7 is 49, and so you could write 7 over 1. What's the square root of 25 since we're talking about it? 5, which is 5 over 1. So then that's all one bucket. That's all irrational numbers. Then there's these things that are considered not even real. So it's not even, if you put this in your calculator, it would say error. So if I did obviously anything over 13 over 0, that's undefined. It's not even a real number. Square root of a negative number is not real either. There's no number you can multiply by itself to get negative inside there. And then comes the irrational numbers. So I'll show you that all in a calculator in just a second. So your irrational numbers, okay, here's a nice definition that I've written in the past. So it says irrational numbers are numbers that cannot be written as a fraction. So there's no ratio of 2 numbers that will give you that number. The decimal basically goes on forever with no pattern. The most famous one of all, we actually have a day for it on March 14th, is what? Pi. And some of you guys can probably repeat it to quite a few large number of decimal points, but it goes on forever and ever and ever. Sometimes you'll see a dot, dot, dot at the end. That's math way of saying that it's irrational. It's going to go on forever and ever and ever with no pattern. And then, so where are all the other rational numbers? It's basically these square roots. So any square root that's not a perfect square root is irrational. So like the square root of 10, square root of 15, square root of 97. Those are all irrational. So it's important in this unit that we understand or know our perfect squares. So that's why in the beginning of your packet here, these are all your perfect square roots. So square root of 1, 4, all the way down. Square root of 100 is 10 times 10, which is 10. 8 times 8 is 64. So all the numbers, so say I stop here, all the numbers, all the square roots between here and here are irrational. So square root of 37, square root of 38, square root of 39, square root of 40, square root of, all the way till I get to 48. These are all considered irrational numbers. So to prove that to you in a calculator here, so if I just go online calculator here. So again, we were talking about not real numbers. Let's start with that. So if I put a not real number, 8 over 0. Oh, wait, infinity. I disagree. Let me try that again. There is no such thing as 8 over 0. Let's try this. Square root of a negative number. Square root of negative 5. Infinity. I guess let me use a different online calculator. I don't like that. Okay, I don't like the way it was saying those answers because it's not really infinity. So let's see here. Sorry for the delay in the video. So if I put this on in full screen here, if I do, now let's do 8 divided by 0. It should say error. Error. If I do 77 divided by 0. Error. That's literally not a real number. There's no such thing. Same thing if I do like square root of, let's see here, negative 6 equals, wait, hold on. How does this work here? Square root, oh, I think I gotta go like this. Negative 6, then I press square root, error. So any negative number I put in here, negative 100, even though we know this, what's the square root of 100 again? It's 10. But if I square root a negative 100, it's an error. So that's just kind of the basics of rational, irrational, and not real. I forgot to show, of course, the most important, irrational. So if I did, we talked about the square root of 48 not being rational. So if I press 48, and I square root it, can someone predict what's going to happen in my calculator? Hopefully you said it would just be a whole bunch of numbers after a decimal with no pattern. Press equals, and it goes on like that. Notice there's no pattern in any of these numbers here. It's just 92820323, same thing. So if another one, like if I did, we know the square root of 9 is 3, but what if I did the square root of 55? Again, that's irrational. It goes on forever with no pattern. So I'm going to get cut off by the bell for lunch, but maybe we can do a few before this video has to end. So if you turn to page 5, I wanted to classify or practice classifying these numbers as rational or irrational. Sorry, let me make this full screen here. All right, so we'll go through a number. You tell me rational or irrational, and then possibly why. Oh, that's lunch. Maybe I'll make another video for that part.